Good afternoon, everyone. We're back for another Tune Into Data event. My name is Stacey, and I am the Digital Marketing Manager here at Future Anthem. So I'd like to thank you all for tuning in again, and welcome to all our first-time attendees. It's great to have you with us today. Before we begin, I would like to quickly share with you about Tune Into Data and how it started. Future Anthem's mission from the beginning was to create a new brand category called Game Data Science that empowered operators and studios to deliver never-seen-before outcomes for their players. While working with some of the industry's best and most forward-thinking brands, including GameSys, Betfred, Entain, and Paddy Power, to name a few, we have managed to ingest 45 billion player transactions. Earlier this year, we won an EGR award for Rising Star, as well as being recognized as one of the UK's fastest growing AI-driven scale-up businesses in the Tech Nation Applied AI 3.0 program. One thing that has always been important to us is to give back to our community, and that is why we have created this space, and that allows us for the sharing of insights as well as to educate and inspire our fellow professionals. So with that being said, I'm really excited to introduce to you three of our very own Future Anthem team members who I know are going to blow you away with their knowledge and expertise. So firstly, we have Ed, who is our head of data at Future Anthem. Ed has a PhD in machine learning and has been working in the gambling industry for 5 years with a special passion for creating responsible gambling models. Next, we have George, who is a data scientist at Future Anthem and has 8 years experience in machine learning within various industries, such as finance, insurance, and gaming, and has also worked for great brands such as Microsoft, TUI, Arcadia, and Vodafone, to name a few. Finally, we have Younes, who, although is in his early stages of his data science career, after transitioning from engineering, he is able to offer a fresh outlook into the current state of data science and utilize his technical skills. So I'm going to hand over to Ed and George and Younes, who will expand more on AI and Azure and how a data scientist analyzes 45 billion spins. Over to you guys.
Cool. Thanks, Stacey. Much appreciated. So thanks everyone for joining our Tune Into Data session today. So, you know, as we're kind of delve into the platform or approaches or technology or processes of, you know, how we've kind of grown Future Anthem to be the success that it is. Let's give a bit of context here, kind of why we're doing this. Is in we're trying to show you as Future Anthem, we're trying to basically always create insights into, you know, player behavior, so we can, you know, as people know, Future Anthem, into recommendations, into bonus optimization, game recipes, and correcting players. But so that's kind of the context of what we do. But this is kind of to show you the tools, like I said, the process and technology we do that help us to do this. So first thing I'm going to say is, excuse me. We are spoiled here at Future Anthem because we have no legacy tech. We're complete greenfields. We're basically starting like, all right, what's the state-of-the-art technology that we can use that will allow us to basically do these insights, grow at scale, run across billions and billions of spins, you know, work in real time. So we are blessed in that case, because, you know, I have worked at big PLCs where you go down to the server room and there's like basically an antiquated, you know, Java machine that basically the whole is a linchpin to the whole process, a spaghetti infrastructure. That if you turn off a light, that basically that could take down the website. So I have a certain I have a certain sympathy for people in that situation, but we're very blessed here, very blessed here at Future Anthem. Actually, just to speak a bit about that, actually, because as Stacey mentioned, you know, I had a previous life in academia for a number of years. That I greatly enjoyed, but, you know, because I've kind of seen data science grow from almost its inception to where it is now, it's just amazing to see what we can actually do. And just to give a bit of a kind of background and some of the evolution of that is a story I like to tell is that back in the day when I was in my research lab and I was creating these models for sports science, we do basically a bit of hyperparameter tuning. So for those who aren't aware, just basically trying to find the exact the right variable for models that really make it as accurate and as precise as possible. But you know, I was only working on a desktop machine, you know, pretty slow, and obviously with sports science data, the copious amount of data associated with that as well. So, you know, to run it on its own, that one machine, it would take me like 3 weeks. And obviously we all know that like there's bugs involved. So if you run a week and notice a bug, it's not ideal. So to basically speed up the process, I used to have to stay after work when everyone's finished, install my code and the rest of the lab's machine, stay till late to make sure it's running properly, run it overnight, save the results, come in early the next morning. And for those who know me quite well, obviously I'm not a morning person, so it's actually coming early the next morning to make sure everyone's PC was ready to go wasn't ideal. But that was how I basically done my parallel computing back in the day. Whereas, you know, with Azure, with our clusters, it's basically a click of a button, boom, scale up, scale down, and you get your results. And even more recent, when I moved into industry, I was working for a big gambling PLC. And on the first week that I joined, they gave me a laptop. Basically, I had to almost dust it off. It was so old. And I was like, you know, is this a joke? Like, what's going on here? It was like, it wasn't Windows XP, but it was probably not too far off it. And basically, I had like a SAS model on it. And for me to create my models, create my codes, I basically do massive exports, not quite floppy disks, but not too far off onto like some old USB stick, bring it onto the laptop. Then from the laptop, I would have to run it on a SAS, which I was not comfortable running it all at all, then export it back. And that would take like half my day. Do you mean, like, and that should have been automated at nighttime. So as in I have so basically, you know, when I'm happy about how blessed we are here, trust me, I know, like the rest of you, have had my trials and tribulations going forward. George, you've had some issues in the past, haven't you, with some of these things?
Yeah, so I have a bit of a broad view on the way that the technology evolved, because I started working as a data science 8 years ago. And one of my first projects in London, I worked for a financial institution, and the volume of data was significant at the time. But the computational power that they had was non-existent. So there was no setup for you to work as a data science. And in fact, the first cluster that I worked with was at this company, but I had to build it myself with my colleague, and it was just underneath my desk. It was just three computers.
The job description, was it?
Almost. Yeah, so we had to build this thing ourselves, and it was underneath our desks. And the challenging bit was to install this software that now you take for granted, that you just open your account and you got Spark. That took me like a couple of weeks on working on blank screens and just with white letters. And the only thing that you would add was the wish of good luck of your colleague, and on you go. Yeah, there was no tutorials. It was very, very hard to debug. And then things developed, and at the moment we are on a state that it's very easy to do data science work. And it's not guaranteed that you move into a company and just because they have a big name, you will have a system like this with no legacy, and then they just at the tip of your fingers. Because, for example, around 2 years ago, I was involved in a project with this massive telecom, and I was just in the process of migrating everything from the servers into the cloud. And I was doing this migration, and that was a really hard job to do because of all the legacy that they had, and everything was on pause. The data science team they were having issues working because we were in the process of doing everything. So Databricks really facilitates my job as a data science. I can work efficiently and on a fast pace.
Yeah, 100%. So this, like, I suppose this is good a transition as to jump into like what does our tech stack kind of look like in the background. So we are basically, you know, we're completely in the Microsoft Azure platform. It works really, really well for us, you know, in terms of speed, efficiency, and even cost. That's something that I had to pay particular attention to. But and as George said, that we use Databricks. For those who don't know, basically it's kind of a node-based online Notepad, probably Notepad kind of based infrastructure. And what's good about it is like we've set it up in terms of security and access that as soon as George basically opens up, or Younes for that matter, opens up a notebook, it directly connects to our data lake. They don't have to do any connections, don't have to do any, you know, just stuff like that little stuff every morning that either can break very, very easily or just kind of waste time. So it's, you know, we want our data scientists to have as easily accessible or access to our data as possible, obviously in a secure manner. And we obviously utilize our data lake to full resource, because we can create storage accounts very easily. We never have to worry about space or things running out. You know, we store in a Delta format, which means is super optimized, super fast access to the data. And it just, especially coming from SQL tables at previous companies, it's the business. But I actually, well, let's talk about as well, you know, obviously, you know, security is a hot button issue, you know, almost every day it gets even more and more important because you hear of breaches and attacks. But, you know, just a piece of advice I'd give to anyone who's kind of thinking about security in terms of their organization is that there's kind of two main fronts, at least in my opinion, honest. So people are thinking about like the platform itself from, sophisticated attacks. I'd also recommend that you worry about users as well. So in terms of just worry about the platform in terms of public endpoints and, who can see what data and, proper whitelisting. But in terms of the users themselves, we make sure that we use MFA with all our people. Sometimes it gets bits annoying. You might have to log in multiple times a day, but to give that, and we obviously have scripts that, look for unusual behavior. It's kind of crazy, but I would just kind of highlight that. Don't forget about that. Security isn't something you should just think of, once a quarter. It should be something, that you build in to your platform kind of going forward. One thing I'd like to just quickly talk about, because probably what we are most proud of here at Future Anthem is our real-time data kind of infrastructure of how we're able to ingest real-time data. So for example, a person's sessions are betting away on a slot game. We've taken that data in real time. And before they've even, in a matter of milliseconds, we can pass that data into our models and then output a result or a recommendation back to operators, which is very, very cool. So I know that basically people here, like, I know you've got legacy tech problems, but I'm sure everyone has real-time, models at least on their roadmap. Maybe not this, definitely not this year, but next year, maybe the year after. But it's like a when, not an if you go to it. So we're able to basically do bonus recommendations real time. Player safety, there's been a big onus as player safety. They're able to score players in real time if they're having a problem and interacting with them. Interacting the next day or the next week isn't ideal. So we use a Kafka cluster for that. It allows us to connect to multiple different options of if our clients have Kafka or even RabbitMQ, a bit more older technology, seamless connection. I'd almost say we have less issues or real-time infrastructure than we do like our daily scheduled jobs. But I won't even get into that. It's kind of amazing. But I'm going to jump into George here in a couple of minutes and Younes to give like a bit of flavor of some of the specific data that we do here. But I'd just like to give some hints and tips to people if they are basically thinking about creating a cloud solution platform, and what have we learned over time. So basically, if you're using Databricks, if you schedule jobs, they're actually much cheaper. So instead of just ad hocly running codes in a manual process, it saves a significant amount of money, which is really good. For the more complex, orchestration kind of jobs, ADF works really great. So Azure Data Factory, you can run event-based pipelines, proper logging, proper notifications, as in really seamless, really reliable. Use spot instances when you can. Spot instances, basically, if you're running something overnight and it doesn't need to run at the exact time, you have a bit of bandwidth where it needs to run. Basically, you can rent servers or clusters at a cheaper rate from Azure, so that can really help you save money over a long space. And I'm rambling here, but I know everyone wants the hints and tips, so I want to get it out there so people can learn from what we've learned over this time. And the last one, probably arguably the most important, people don't realize, which it's actually storage is almost the biggest cost. Actually, it isn't. It definitely is the biggest cost, especially when we have 45 billion spins. And a real way to really optimize that cost spending is to use something called tiered storage. So you can have hot storage that you access all the time. Then you got cold for something you access less, and then archived. You might be aware, but just in terms of the costs, it's night and day. So if you've got a proportion of your data, that that it's more for archiving or for regulation purposes that you don't need to access regularly, please use the tiered storage, because it really does improve basically cost. So George, I've rambled on about kind of our infrastructure here, but you're deep in the coal mines, actually doing proper data science, not me just tapping away, creating processes in the background. But you've done amazing work on our RG models and grown them to like if I do say myself, like top tier kind of approach. You maybe just talk to maybe everyone here and kind of inform them, how did you create that? What was the process? What was the evolution of those models?
Yeah, so when I joined Future Anthem, I was given the task on carry on some previous work that was done on RG. And the first thing that I do to get familiar with the concept and the problem, it was to go and read papers that were published on academia about responsible gambling. Now, after going through a few of those, I've noticed that all of the work on modeling was done using a technique called supervised learning. Now, this technique relies on labels, and the labels that we have on this industry that we can use are produced by the usage of players when they interact with these RG tools. So as you may know, Ed, the use of these tools is not always perfect because players that have a problem will not interact with them. And sometimes players that do not have a problem will just interact with them just because they either they don't want to receive any emails or they're just upset with the website.
It's almost counterintuitive, basically. Like, you know,
Yes.
that I found very interesting, that like you'd expect that, right, not every player who has a problem self-excludes. So, you know, your target variable is missing some stuff. That's understandable. But as George just mentioned, the, you know, adding in noise from people who actually don't have a problem self-excluding, you know, really kind of creates issues. So then, you know, we went back to the drawing board, George, and kind of figured out a different alternative to make sure we captured harmful play, didn't we?
Yeah, so we had to move away from these labels. Firstly, because they are not the best way of going forward to produce a model. Also, we don't have access to them. So we had to go and utilize unsupervised learning techniques. And one of them is called clustering. So basically, we're going to try and group players according to their behavior. Now, when starting this, I had to take in consideration two things. The first was the nature of our business. We are a consultative-based firm, meaning that we work with different clients. And the second one was, as this was kind of groundbreaking approach, as in nobody had done it before, I knew that I had to experiment with more than one model because it was likely that I was going to fail at the first go. And if I didn't fail, I would like to have some sort of a baseline so I can go back and compare if I was doing further development the right way or not. To tackle the first issue, which was scalability, given that we work with different clients, this was possible because we have a whole process of pipelines that creates a standardized data schema that we can work with. So no matter what client we onboard, we have all this process that runs on the back end of our system, and they just deploy the data into a location that we all can work. And the data has the same format and is clean and is reliable. So this one was already done for me. I just had to worry about my code, and I knew that when a new client comes in, I can just plug in and all the models that will run without any effort.
I hope you send the engineers your Christmas cards. They're the ones make your life very easy.
Yeah, every year I send a Christmas card saying how thankful I am. The next one, it was to do with the modeling itself. And as I had deadlines, I had to find a quick, efficient, but also reliable way to work. And I started badly because the first approach that I did, it didn't work. So I thought of building this massive matrix with a lot of metrics that will reflect the behavior of the customers given some session. As these metrics, they were huge, I blew the memory of the system. And, sorry?
Covariance matrices, wasn't it?
Yes. There were covariance metrics. So I blew up the memory of the system. And on that situation, I didn't blame the system. I knew that I was doing something wrong. So we had to go back at some discussions that we decided to take a different approach. It was simpler, but more effective. The problem with this approach was that on our data is extremely skewed if you consider the number of sessions that the player goes and plays. The majority, not the majority, but there's a big number of players that play 1 or 2 sessions and then leave. And on this particular problem, we had to take in consideration the past history of the players because we are interested in seeing if your behavior today is any different on the behavior that you had when you played before on the platform. If we eliminate the session 1 and session 2 of the players, we are losing a lot of information. So we had to change the approach again. And as we were working with clustering, I had to go through several permutations on the fictions to select, and I was dealing now with 2 different approaches. So this
George,
was, yes.
Just to give people a flavor, like you're dealing with billions of spins here, aren't you? So, you know, these models are actually, you know, they're churning through a lot of data. Is that correct?
Yes. So I had 2.5 billion of spins for the client that I was working at the time. And I had to train 3 different models as well. And the first iteration of this last approach that we've taken, it was taking from end to end roughly 3.5 to 4 hours to run. But it was far from being optimized because I was utilizing a lot of UDF functions, which are, it's a function that you can write and incorporate into your Spark code. So it's not a native Spark function. And what this does to your processes is that they get them really slow. So I had to improve this by rewriting these UDF functions on native Spark code. And then the time of the processing drastically decreased. I went
just,
for
just a piece of advice I just give the listeners is, I actually, I wouldn't say never write UDF functions or user-defined functions. Excuse me. It's really good for prototyping code because you want to get it finished. So what George is alluding to is that, like, get your prototype finished first, get it all working, and then try to optimize afterwards. And by kind of removing kind of Python packages, because they generally don't utilize parallel computing to its capacity, it's when you start to rewrite the code is then you can get real optimizations. Isn't that right, George?
Yeah, so just by making these smaller changes, I saw the time of processing decrease a lot. So it went from like 3.5 hours to 45 minutes to 1 hour.
It's amazing, isn't it?
Yeah.
Cool. So is any other kind of tip? So I think that's the main one I'd always give, is that prototype 110% your code, but please don't forget afterwards that there's so many different optimizations to go. So that's basically what 2.5 billion spins. Was that like what 300,000 players, George? Is that right?
More, it was closer to 400,000 players and 2.5 billion spins. For that given client. But we work with biggest volumes on different clients. I believe that there was a particular one that we had more than 400,000 players and like 4 billion spins, and the code just ran fine. So it was just a matter of pointing our pipeline to the location of the data of this particular client and rerunning it. And it took like an hour as well.
That's amazing. So I'm probably going to jump on. I'll probably jump back and forth because Younes, you worked on the latest GameSys research that we published, that basically focused on trying to find any links between markers of harm and game features. Is that correct?
Exactly.
And how did you go about that? Like, as in, how are you able to utilize kind of our resources to kind of help you answer those questions?
About that, I should say that there was a concern about the impact of casino games, particularly slot games, on players' behavior. And also, there were several academic research claiming casino games and their respective structures can cause problematic behavior. More particularly, they were proposing some casino games, due to their structural characteristics, can impact players' behaviors more severely. Given this situation, we decided to start an investigation in partnership with GameSys to understand whether different slot games can influence players' behavior in different ways. It is worth mentioning that none of previous papers we encountered have done research on this area. I mean, none of them had investigated the impact of different slot games on players. So let's say we aim to investigate where there was a gap in research. By the way, it's good to mention that we recently published a white paper based on that research on our website. So if I want to brief the process, to do the research, we had to work with more than 2 billion transactions and several data sets. The goal was to find problematic patterns in players' behavior, also known as markers of harm, like loss chasing and immersion, and see if they are correlated with game mechanics. To do that, we analyzed loads of data.
So when you say game mechanics, it was basically volatility, hit rate, and RTP.
Exactly. So to do that, we analyzed loads of data, created several features, and used results of one of our existing AI models, the one that George was talking about, Anthem Safer Play, which tracks and scoring game players' behavior. We also defined several hypotheses and used a number of parametric and non-parametric tests and data mining techniques. And eventually, we came to conclusion based on our findings. The bottom line is, we learned when considering only slot games, there is no significant correlation between game mechanics such as you mentioned, RTP, volatility, and hit rate, and problematic behavior among players. It is an ongoing project, and we are going to include other game mechanics as well. Something that I should mention here is that previous research compared the impact of different casino games. For example, they looked into lottery and slot games and concluded that one of them can significantly worsen players' behavior. There is a huge difference between these games. You can buy a lottery ticket today and find out about the result in 1 month. In contrast, while playing slot games, players click and the result pops up immediately. That's why these can impact players in different ways. In contrast, when we repeated the experiment with only slot games and look at the distribution and variance of their game mechanics, we noticed that the differences are too subtle to impact the player's behavior.
Yeah, from the basically the mechanics that we looked at, but as you said, we're very interested in looking kind of other specific game features, so as in, like, you know, bonus modes, team, you know, even the sounds. There's so many, you can go so deep in these games. That's fascinating. So just so that people are aware of, like, why we have the three of us basically on the call, and why Younes looks so fresh-faced compared to the rest of us. George and I look a bit haggard because, as I've alluded to, that, you know, we've had to go through all these generations and evolutions of technology. But, you know, Younes just comes in day number one and go, write some code and run a couple of clusters, and be able to create models and do analysis at, you know, within a couple of minutes. Whereas George was probably afraid. We're not afraid, George, that like that might catch fire, having the can imagine how hot it was that time, having that machine under your desk as well as another machine as well to actually do the work on.
Things were a bit hot at the time, yeah, sometimes.
Oh, I can imagine. Oh, I can imagine.
And it was every day it would break. So yeah.
Yeah, I can imagine. I then, for us, it's just the ability to plug and play with the technology we have is just makes it so convenient. There's one kind of quick thing I'll mention there that I saw is that in terms of the configuration of the clusters for Databricks, there's a couple of different options you can make in terms of like memory optimized, storage, or compute optimized. Generally speaking, I don't know, George, you probably have a better opinion than I do on this, but I kind of see very real, or I don't see any real differences in performance. You know, as in we're running our Spark scripts, we just basically create clusters. There's different types of clusters you can create in terms of like the size. So obviously the number of workers that you can do, and the size of the memory itself. But generally speaking, like, I don't really see, so I wouldn't worry about it, because when I was first started creating Databricks, I was kind of worried about that. Or am I setting the settings absolutely correct? Just a word of advice there if you are setting it up. Well, don't worry too much. Obviously worry about the number of workers and the cost. In terms of like memory optimized, compute optimized, it's not too much difference. But yeah, I think that's basically us.
Great. Thanks so much, guys. It's been an absolute honor to hear you speak and share your knowledge and expertise. I would also like to thank our audience for coming to join us today. And in case you did miss anything, you will be receiving an email tomorrow with a recording of the talk. Make sure to also look out for our next events by following our LinkedIn page, Tune Into Data. The page link will be included in the email that you receive tomorrow, as well as contact links that if you would like to find any more information out about Future Anthem, as well as a link to our GameSys research that Younes spoke about earlier. We look forward to seeing you at our next event. And once again, thank you, Ed, George, and Younes.
Cool. Thanks, everyone.
Thank you.
Thanks. Bye.
Bye-bye.